Hi, this is Gerry Donohue with ACEC with another episode of Engineering Influence Podcast. One of the most exciting technological developments in the AEC space in recent years has been the digital twin, and Bentley Systems is a leader in this field. To learn more about it, we're talking today with Adam Klatzkin, who's Bentley's Vice President, Business Development for iTwin Services. His team is responsible for the firm's digital twin cloud services for infrastructure engineering. Welcome, Mr. Klatzkin. How are you?
Great. Thanks for having me, Gerry. I'm excited to be here today and talk to you about digital twins.
Great. So to give myself and the listeners a firm foundation in what we're talking about, what exactly is a digital twin?
So try to very simply describe it as a digital asset that you can trust represents a physical asset as it exists today, right? And typically they are joined together and kept in sync so you can leverage the digital twin to understand what's happening with the real world asset in real time, have visibility into the real world asset without having to leave an office, collaborate easier around it, and more effectively with distributed teams or stakeholders, and ultimately to make more informed decisions that lead to better performance. It might be better project performance if you're designing or constructing the asset. It might be better operational performance if the asset already exists. But that's the end goal and the value to come out of it. I'll also mention that, of course, as a twin, that relationship is and should be symbiotic between the digital and physical assets. So you can imagine this continuous feedback loop of sorts, right? The analysis and insights that happen within the digital twin become actions and interventions that feed back to the physical asset, result in outcomes or changes that feed back to the digital twin, and that cycle just continues. And there are lessons to be learned and mined, and the impacts of decisions that are made along the way can be digitally captured. So ultimately, an organization leverages digital twins is not only going to reduce costs and risks for a single asset, that digital transformation can allow them to optimize performance across an entire portfolio and future projects as well, based on the lessons that have been learned.
Well, that's quite comprehensive. What to take it down just to a single project, say for example a bridge or something, how would an engineering firm use a digital twin in the design and construction of a bridge?
So that's it's a great question, but to answer it, honestly, I'd like to start with kind of the ugly truth and challenge, some of the ugly truths and challenges of an infrastructure digital twin for any type of engineering project, a bridge, being one, to better understand what you would need and how you would work with it. So the concept of digital twins isn't new, been used in manufacturing for years, but why haven't they really been adopted in infrastructure? One ugly truth is the data, right? Engineering projects tend to have massive amounts of data. We've seen bridge projects that have multiple design tools in play by trade or discipline. There's modeling tools, geotechnical, structural. Beyond just design tools, there's tools for and data for analytics and simulations, scheduling, resource management. The list goes on. All of that data is siloed. It's all typically understood by a single application or expert users and not available in other contexts. Even worse, engineering projects have tons of change, and that change is relentless. It's the nature of an engineering project. If there wasn't change happening, then the project isn't progressing. So that's one ugly truth. The data is a mess. The second is no one vendor could ever provide a digital twin that was, locked into their ecosystem. If we consider that bridge example, and I said there's many different tools in play, we've seen many projects that use a combination of Bentley products and our competitors. There may be AutoCAD, Civil 3D, Bentley Open Roads, Bentley Open Bridge Designer, all may be used on the same project and others as well. So to even get started with a digital twin, or to even get started, a digital twin platform is needed to address those ugly truths. And that platform needs to be able to align and federate data, together all this data coming from those many different vendors. And it can't, the platform can't just handle the relentless change, but it has to leverage it to provide better change management and insights based on the impacts of changes that are occurring. So Bentley's introduced a platform that addresses these challenges. iModel.js, that's our foundational development platform, and iTwin Services, which is our commercial offering built on the platform. And our philosophy around this is openness, open in every regard, open to any tool by any vendor, any repository where data may reside, and we've even open sourced the platform itself. So to come back to that example of the bridge, digital twin platform addressing those challenges in context to a bridge, right? You would consider that maybe very early on in planning, the most important thing to understand for the engineering team through the twin would be the physical location, the site where that bridge is going to be designed, engineered, ultimately constructed. So reality capture could be used via drones to establish a 3D mesh. Right? That's one example. There's other ways to get reality data too. That could be combined together with map data, terrain data, and all brought together in context of a digital twin that is the basis and leverage for planning. This gives anyone at any location access to the true site conditions. Those drones can be flown as often as necessary to keep that digital twin that's just a reality model right now continuously surveyed and synchronized. And now as design and engineering progresses, the files that are created from design tools today, they'll likely reside in a connected data environment like ProjectWise, Bentley's offering there. And connections are established between the digital twin and the files in the connected data environment, the design files, through things that we happen to call bridges, overloaded term in this context. But they are bridges that bridge data from the connected data environment into the twin. They understand the native formats that are in play, all those silos. They detect changes as those changes occur. They make those changes available in the digital twin, and they align all of that disparate data together into a single digital representation of that physical bridge that you're engineering. And as these changes come into the twin, right? As I said, relentless change. As they come into the twin itself can validate the trustworthiness of that data through data quality services, right? And this is all automated, validated against codes and standards and whatever other rules the engineering team might want to dream up as well. And immediately, the engineering team can start recognizing the benefits through workflows such as integrated coordination and design reviews, where they've got all of the richness of of not just having the mirror of that what they're designing against the physical reality, but understanding what has changed across all this disparate data that's been aligned together. What changed? When did it change? Why? Where? They can do clash detection against that continuously up-to-date twin. They can do issue resolution. So you get all those benefits in easy web-based accessibility without requiring any installed software. They can make it available to clients for communication, to public stakeholders, whoever else may need access as well. And then they can start to, as it continues, they can start to introduce connections to other systems and information. Like, for instance, maybe there's a risk register or database in play, hazards and such, that they can connect that information into the digital twin and have it, for visual sharing and recognition. They can run simulations against the digital twin. They can run insights and analytics to understand, okay, well, these changes that occurred over the last period of time since our last coordinated design review, what's the impact of those changes on our costs, on our schedule, on risks, and have those dashboards all recognized through the twin. But most importantly, as they go through this entire process, it's not intended to be disruptive. Those engineers and designers are still using the tools and the systems that they use today. They get the added benefit of the twin it being complementary to those systems where everything's being brought together for those integrated workflows.
And just so I understand right, so if the contractor is using a different system, it would whenever they input something into their system, it would automatically move over into the Bentley iTwin system and be available to everyone else on the team.
That is absolutely correct. Of course, it does have to be configured that way, but that's correct.
So there's no extra work. There's no extra inputting. Anything you input into your own system, if everything's configured correctly, works its way into the twin automatically.
Not disruptive. No extra manual intervention. No duplication of data. Yep.
So you mentioned earlier that one of the reasons why digital twins haven't really made it deeply into the engineering industry so far has been just the huge amounts of data. How deeply into the industry have twins come? Have you a lot of clients out there? A lot of potential?
There is a lot of clients, a lot of potential. There is, no doubt it is emerging technology. So, anecdotally, I can tell you there isn't a single firm I or our teams here have spoken with that aren't exploring or implementing their digital twin strategy. But there's also some interesting third-party research showing that the digital twin market in very short order is actually going to surpass that of BIM. Now, that doesn't mean BIM is going away. It has incredible value, and that BIM market's going to continue to grow at a respectable rate. But digital twins don't replace it. They complement it. They advance it, and they enable further digital transformation, right? The use cases, workflows, benefits are much more unbounded in a digital twin than they are in BIM, which is a static file representation at a moment in time. Those projections and that research show that in 2024, the BIM market size will be 13.2 billion with an this is US dollars, of course, with a 18% growth rate. While in 2025, they're skewed by a year. 2025, the digital twin market will be 29.1 billion with a 37% growth rate. If you look at the charts, it's amazing at where they intersect and the rate at which digital twins continues to grow. As for today's adoption and initiatives that are out there, again, this independent research, not by Bentley, is showing that about of all the digital twin initiatives that they've surveyed, about 16% of those are being driven by engineering and engineering firms. 33% of them are being driven by operations and owners, and the remainder of those initiatives are being driven by supply chain, finance, and others. So it is definitely skewed right now towards owners and operators driving it, but there's a significant drive within engineering services firms directly. Leading the way by industry penetration of digital twins is transportation. They have the most, again, in the same survey, they have the most digital twin projects that are implemented, budgeted, or planned within the next 3 years. Transportation is definitely a leader, and that seems to be followed closely by plant, particularly oil and gas, then chemical, and then metals and mining.
All of those things you mentioned are big projects, big infrastructure project, a big factory project. Is there some sort of size limitation for when a digital twin is effective, either affordable or can you do it on a small project as well as a big project?
Yeah, from our perspective, the commercial model scales. It's not inhibitor for any size project, and the benefits certainly apply to all ranges as well. But as far as penetration in the market, those are the areas that seem to see the most activity underway. The industries and types of assets that see the most industry underway right now.
When I was reading about this and the stuff that Bentley's written about digital twins, a statement that came out that sort of struck me was that a digital twin is a connection of data sources. Would you talk about that?
Sure. Yeah. If we go back to those ugly truths that I mentioned earlier, a project or asset may have different sources of truth for information, right? The source of truth may be some bespoke database. It may be an enterprise database. It may be a design file. It may be a connected data environment involved that is a collection of those sources of truth of information. A digital twin should not be a source of truth. It's a view of truth. You can also look at it as a single pane of glass. That's another descriptive term we like to use. The digital twin needs to be a federation of all the relevant information and data sources wherever they reside, brought together into this single pane of glass. It would be a losing proposition to say that data needed to move somewhere else in order to create a digital twin, and we chatted about that earlier in this discussion as well. But generally, we're talking about three types of data sources across an asset life cycle and the connections that might be formed. ET, IT, and OT, data coming from engineering technologies, informational technologies, and operational technologies. The digital twin needs to federate all of this to make information easily accessible in that single pane of glass for immersive visualization, for analytics, for improved decision making. So those are the types of connections and data sources that we're talking about. And just to give some examples, engineering is definitely obvious, but when we say OT, operational data, we're talking about data coming from IoT feeds, sensors, cameras, etc., and informational or IT data. We're talking about data coming from asset registries, maintenance records, and inspection records, and such.
If for a digital twin to work, does everyone have to be playing the game, or can a team work if one member doesn't play?
Sure, it can work if one member doesn't play. I guess it depends the team you're referring to. Are you referring to the engineering team? Which team do you have in mind there?
The project team, I guess, would be with all the different players that need to collaborate to go back to our earlier example, to build a bridge. If one of the one of the designers or one of the constructors decides not to play, can it still work?
It can still work. The value is only going to be great as the data that has been federated into the twin. So if there are members that are keeping data out of it, there will be constraints on maximizing the value of all of the asset data in creating that digital representation of the physical thing you're trying to design and build. But it's absolutely still viable. And actually, our premise is get started easy and quickly with the data you have at hand. There are use cases that can be developed out around it, and you'll recognize more value as more data is connected into the system.
And another thing that you had in your documents was a sort of an intriguing statement, which was opportunity and optimism are the value that a digital twin can bring to the infrastructure industry. I was struck by the word optimism as well as opportunity. What are you saying there?
Yeah, so we're seeing digital twins really present a new business opportunity for engineering services firms that have been exciting to us and exciting to them. And I say this anecdotally via the many conversations I and our teams here have had with these accounts. We're talking to many that see it as a way to create new business opportunities and deal with challenges such as aging workforce, labor shortage, shrinking profit margins, et cetera. There's an opportunity not just to do things more effectively and efficiently, but also an opportunity to create that new business model where they start delivering digital twin services to clients and therefore expand more into operations and maintenance, particularly from a data perspective, right? So to create that digital twin, hand it over, but also maintain it into the future, because it doesn't magically maintain itself. There's effort involved in curating and continuing to grow the connections of information that may be accessible or pop up over time into this digital twin. So these firms are looking at the opportunity to kind of maximize the value of all of the owner's data into operations, provide digital leadership and transformation to the owner during operations, and really focus on following that data and maximizing the value of it over the entire asset lifecycle. Right, pays dividends for the entire life of that asset. And the reality is, somebody is going to do this. Right, I said 33% of the penetration to date and initiatives to date is being driven by owners. They're interested. So someone's going to do it. Who else is better situated? Engineering firms have created the content. They understand the data best. Really distinguishes them from a run-of-the-mill systems integrator that's going to raise their hand and fill that void if nobody else is there to do it. So that is what is generating a lot of the opportunity and optimism around the value of digital twins, beyond just the efficiencies alone they'll introduce to existing processes in engineering.
And I would think a sort of another benefit of that would be you're maintaining the relationship with that client after the project is over, and that maintaining that relationship opens you up for potential business opportunities with that client in the future.
Business, absolutely, yes.
For firms looking to use a digital twin, Bentley recommends being flexible. What do you mean by being flexible in this context?
Yeah, so there's certainly multiple perspectives from which to look at flexibility. One is we have to recognize, I said this earlier, that digital twins are emerging technology. This is not a mature solution that's been in the market for years. This is something that is being developed out at cloud speed at the moment. And that is that comes with the recognition that change is going to happen quickly. The services that Bentley is pushing out, right? This isn't an old school product that's going through monolithic releases once a year. We're pushing out new functionality on a regular basis, fixes and new functionality. So there has to be flexibility in an organization's from an organization's perspective in how to keep on top and learn and increase their maturity with this technology as new capabilities are introduced. So flexibility to learn and pick up quickly what's coming out. The second aspect I'd say for flexibility is flexibility in the use cases, scenarios, and connections that you may establish and use the digital twin for. A digital twin is a Swiss Army knife of sorts. So there is tons of things that you could consider and benefits that could be recognized, and you should have flexibility in evaluating those, continuously evaluating those and your benefits over time. The third is, as I said earlier, we have a open source platform for digital twins that we call iModel.js. And that's a development platform. So many engineering firms have their own in-house development teams. And if you do, you should have flexibility in those teams, evaluating the platform, leveraging how you might develop out automation, integrations to bespoke systems or other systems if you have them, new tooling you could add, even creating your own IP around the digital twin using this platform. And then the last thing I'll say about flexibility is it's great to have vision and a long-term plan, but don't focus on conquering the world from day one. You can get started quickly and easily with a digital twin on some scenarios and use cases that will bring immediate benefits. Find those lighthouse projects, get started and understand the technology, and the plan will come from the long-term plan will certainly come out of that. But as this technology is emerging, things are going to change, and you have to have flexibility to adapt.
And talking about this this technology changing, you use the term cloud speed. It's a rapidly changing technology. Where do you see it going in the next few years? Beyond growing rapidly?
The thing I'm most excited about is the potential, if I hone in on one, is the potential for machine learning. Right, the amount of data that will be collected within the digital twin due to all of the changes, everything that's being connected into the digital twin, is going to make it very easy to take some things that were maybe previously required a lot of manual effort, and to leverage artificial intelligence and machine learning in order to do those. Particularly, I'm interested in the lessons learned that can be gleaned from a portfolio of projects. And applying those to future projects, and identifying trends and patterns that resulted in mistakes or cost increases or safety incidents, and leveraging machine learning to flag future projects as those types of scenarios come up again, to flag those in advance and provide early indicators. But there's tons of opportunity for machine learning against this technology. So that's certainly an area I see this going in the next few years, and is going to add tremendous value. And the last thing I'll add there is going back to the previous question too, on flexibility and where this is moving. It is incredibly important to get started quickly, because there are many organizations that have already adopted, and if you have concerns about whether this is letting others lead the way and figure it out before you do, you're going to be left behind, and the potential business implications and benefits of changing business models around digital twins, you miss the mark there, could be catastrophic for your firm. So really encourage everyone to start taking a look at digital twins, find that low-hanging fruit, find those lighthouse projects, and get started now.
Well, I would agree with you. After having listened to what these are and learning so much, it seems to me to be the future. I really appreciate you taking the time to speak with us. Thank you so much.
Thanks again, Gerry.